And let's continue to talk about example 7. So example 7, the random variable x is normally distributed with mean mu and standard deviation sigma, and given that p, the probability when x is greater than 55 is 0.05, and the probability when x is smaller than 15 is 0.1469. So find the value of mu and the value of sigma. So this question requires us to find two unknowns. So it means that you have to use two equations, two equations to find the two unknowns, and you see that the question has been given two equations for us, So here we will use the two given conditions to find the two unknowns. All right, so let's start. And the same way, firstly, we should, firstly, step 1, we should simplify the normal distribution to standard one. So simplify the normal distribution to standard one. So firstly, so we have two conditions, x greater than 35. Another one is x smaller than 15. And x is x minus mu greater than 35 minus mu also. X minus mu smaller than 15 minus mu also. And then x minus mu over sigma greater than, because sigma is positive, So we don't need to change the direction of the inequality sign. So 35 minus mu over sigma. And here is also x minus mu over sigma smaller than 15 minus mu over sigma, And this is z, This is z. And then it is normal, It is standard normal distribution. And then we can get z is greater than 35 minus mu over sigma. And here is z is smaller than 15 minus mu over sigma. And we take the probability, so p z greater than 35 minus mu over sigma. And corresponding probability is 0.05. And the second one is all right, so these are the two new equations we can get, And now we can draw the corresponding figure, We draw the corresponding figure. So it is normal one. I mark this as equation 1. So this is 1. This is 2. This is 2. So z is greater than is 0.05. 0.05. So greater than, so equals 0.05. So it must be here. It must be on the right hand side. It must be on the right hand side of the y-axis. So it means this is 35 minus mu over sigma. So why is here? It is because if it is on the left hand side, it is impossible. Because this region must be greater than 0.5. Because half of it, half of the region under the bell shape is 0.5. But here it is 0.05, so it must be this smaller part. This small part. So here it is, this region is 0.05. 0.05. And for another one, for another for the second equation. Okay, so z is smaller than, okay, smaller than this value is 0.1469. So it means that the value of 15 minus mu must be a negative value. Okay, why is negative? It is because if it is on the right hand side, and the value must be greater than 0.5, but now the value is smaller than 0.5, so the value of 15 minus mu over sigma must be on the left hand side. Okay, so smaller than 0. Okay, so it means that the red region, okay, the red region is 0.1469, okay, and the corresponding value is 15 minus mu over sigma. Okay, and however the table, from the table, okay, we cannot find the value of 15 minus mu directly because it gives us the value of z on the right hand side of the of y-axis. Okay, so it means that you have to use symmetry. Okay, use symmetry. So use symmetry. Okay, I'm up here. So use symmetry. This region is also 0.1469, and the corresponding value will be the opposite value of 15 minus mu, so which will be mu minus 15 over sigma. Okay, over sigma. And however, the table doesn't give us the value of so this represent P. Okay, these represent P z greater than mu minus 15 over sigma equals 0.1469. However, the table doesn't give us z greater than mu minus 15 over sigma equals 0.1469, but it gives us capital Z smaller than smaller z, the probability, okay, of this region. Okay, so it means that the black region, okay, the black region represent P Z smaller than, okay, P Z smaller than mu minus 15 over sigma equals 1 minus 0.1469. Okay, so later you can just, okay, so the value is 1 minus 0.1469, which is 0.8531. Okay, so now we get two equations. Okay, so which is P Z greater than 35 minus mu over sigma equals 0.05. Okay, so it is this one. And another one is P, the probability when Z is smaller than mu minus 15 over sigma is 0.8531. Okay, it is this one. Okay, so now for the first one, okay, for the first one, we can use the table which is called, actually on the second page of the table, okay, on the second page of the table, which is called the percentage points. Okay, the percentage points of the normal distribution. Okay, so actually from the table, from the percentage points of the normal distribution, we can get that, okay, the when the probability is 0.05, the corresponding value of small z, okay, is 1.6449. Okay, so it means that from 1, we can get that 35 minus mu over sigma is, okay, over sigma is 1.6449, okay, and however the answer in your textbook is wrong, okay, the answer in your textbook is wrong, so pay attention. It should be 1.6449, okay. And for equation 2, okay, for equation 2, so correspondingly we can find the value of mu minus 15 over sigma should be 1.05, okay, 1.05. So the probability is 0.8531 and the corresponding value of z is 1.05, okay. And then mark this is 3 and this is 4, and we use 3 over 4, and then we can find. And why do we need to use division? Because it is very easy to cancel sigma, okay, because sigma can be regarded as a common factor, so we use division here. So we can get that 35 minus mu over mu minus 15 equals 1.6449 over 1.05, and it will be 1.5657 now, okay. So I choose 5 decimal places, okay. So finally we can find the value of mu, okay. So we find the value of mu. 35 minus mu equals 1.5657 times mu times 15 times 1.56657, okay. So 2.5 mu 2.56657 mu equals 35 plus 15 times 1.56657, okay. So the value of mu we find, so 35 plus 15 times 1.5667 over 2.56657. So it should be 22.79, okay. I choose correct 2 dp, correct to 2 dp, okay. This is the value of mu and sigma, okay. So substitute mu equals 22.79 into 1, okay, into 1. So we can get the value of sigma. So sigma will be, okay, so 35 minus 22.79 and over 1.6449, and it will be 7.42, okay. Also correct to 2 dp, okay, correct to 2 dp, okay. So this is the value of sigma and mu, okay. So finally we get a conclusion. So mu is 22.79 and sigma is 7.42, okay, 7.42, and correct to 2 dp, okay, correct to 2 dp. So this is question 7, okay, question 7. And now let's look at some practice. Let's look at some practice. Okay, so let's look at question 1. Okay, let's look at question 1. So the random variable x is distributed normally. Okay, is distributed normally with mean mu and sigma. Standard deviation is 5, and the probability when x is smaller than 18 is 0.9032, and find the value of mu. Okay, find the value of mu. So let's see. Okay, let's see. Step 1. So question 1, step 1. Firstly, we should simplify x to be z. Okay, so firstly, z is smaller than 18 and z minus mu smaller than 18 minus mu, and use x minus mu divide the standard deviation 5. Okay, so here is 18 minus mu over 5. Okay, and then this is z. Okay, so this is z. Okay, so we can get that p, the probability when z is smaller than 18 minus mu over 5 is 0.9032. Okay, 32. And then now we can use the draw a figure. Okay, it is better to draw a figure. Okay, so normal distribution, bell shape. Okay, and smaller than, it is 9.032. Okay, so this value is greater than 0.5, so it must be on the right hand side. Okay, so right hand side of the y-axis. Okay, y-axis. So this is the region. Okay, so the region is 0.9032. Okay, so the corresponding value of small z is 18 minus mu over 5 here. Okay, so from the table, okay, use a table, so we can get that. Use a table, so the corresponding value of 0.2 to 0.9032. It is 1.30. Okay, so from the table, the corresponding value is 1.3. Okay, it's 1.3. So it means that 18 minus mu over 5 is 1.30. Okay, so finally we can find the value of mu. Okay, so mu will be mu is 11.5. Okay, mu is 11.5. Okay, so this is the way to do question 1. Okay, question 1. And let's look at question 4. Okay, question 4. Look at question 4. Question 4. Okay, so question 4. The random variable y is normally distributed with mean 50 and standard deviation sigma, and when the probability when y is greater than 40 is 0.6554. Find the value of sigma. Okay, the same. So firstly, we should simplify z to be y to be z. Okay, so firstly, y minus y greater than, okay, y greater than 40. So y minus mu is 50, greater than 40 minus 50, and then divided by sigma. Okay, so this is Z. Okay, so we can get that P Z greater than negative 10 over sigma is 0.6554. Okay, so after that, we can draw a figure. Okay, draw a figure. As we know, sigma is a positive value. Sigma is a negative value. Okay, this is positive. Sigma is positive, and this is negative 10 over sigma is smaller than 0, negative. Okay, sigma is always greater than 0. Okay, standard deviation. And then you see greater than the region, the probability is 0.6554, which is over 0.5. So this value also we know it is on the left hand side. Okay, so this is negative 10 over sigma. This region, okay, the blue one is 0.6654. Okay, and however, from the table we do not have the corresponding value for negative 10 over sigma. Okay, so we have to use symmetry. Okay, use symmetry. Use symmetry. So this value is 10 over sigma, and the black region on this side is also 0.6554. So it means that, okay, so from this one it means that P Z smaller than the positive one, okay, 10 over sigma is 0.6554. Okay, so then we have okay, then we can use the table to find the corresponding value for 10 over sigma. Okay, so 0.554. It is 0.4. Okay, so from the table we can get 10 over sigma. The corresponding value to 0.6554 is 0.40. Okay, so sigma is 25. Okay, sigma is 25. So this is question 4. Okay, question 4. All right, and we have to stop here. Okay.